single sensor robots are so last year. Let's talk about multimodal sensing and how to make these technologies work. Coming up. Ian, what exactly does multimodal sensing mean?
Well, we've talked about it in some of the other episodes, but basically, you've got vision, you might also have lidar, you might have radar. There's other types of sensors as well. So that's what we're seeing is how do we start to integrate all these things together? And what we have here is a example robot platform. It's got a companion computer already. It's got vision already. It's got a little lidar sensor. And we're going to start looking at how we would integrate this Raivin sensor from Ozone reference design with the same robot. It's running ROS, and the microcontroller side is running Zephyr, and there's Zeno communication, and all of this is well known and standard within the robotics community. So that's what's going to make a difference here. And Sebastian, maybe you can start talking about how we're going to go about integrating this sensor.
Right. Thanks, Ian. So yeah, the beauty of the ROS ecosystem and this enablement that NXP provides, it allowed us on the Raven to just plug into that. You get a list of topics, the different sensors publish on it. We've got models that consume, say, a radar or a camera topic, and then publishes a detection topic where it sees people and
So
things like that.
as far as the robot's concerned, it just gets a whole bunch more topics of
Yeah, we add a new
images and radar and things like that it can work with. Right?
Exactly. New sensors added. It provides the camera radar fusion. It's just a new topic in ROS.
And it's going to connect into the system via Ethernet.
In this case, it's connected over Ethernet.
Yeah.
There's different ways to connect over serial, Wi-Fi, CAN bus, and so on.
So it all becomes part of one robotic system with all these topics.
Exactly.
And then what are we looking at here on the screen? This is a development environment?
Yeah. So this tool, it's called Foxglove. It's pretty common in the ROS ecosystem. And it basically, it speaks ROS and subscribes to all the different topics.
So it's kind of like the laptops are also part of the system right now.
Yeah.
As well.
So in this distributed system, the laptop just becomes a new node. And in this case, it's just monitoring.
Okay.
It can also be used for control and whatnot, but in the case of the Raven, it's a perception sensor.
Yeah.
So it just produces data.
And there's a lot of stuff on screen here.
Yeah. So a little bit busy, but what we're seeing on the bottom left here, this is the radar data. And then on the top left, we've got the camera data.
Oh, there's our film crew. Hi.
The film crew's there. And
oh, and it's picking them up and drawing bounding boxes and everything. That's all done in the sensor.
Everything is running on the i.MX 8M Plus. It's all
not the robot's companion computer. It's
no,
The edge.
Exactly. The laptop is just here to give us eyes into what's going on. The top left or top right, sorry, is IMU. So if I move the robot here, we'll see
the data changing.
Yeah.
Okay, yeah.
And then we see the radar moving around and
all right.
And all of this for a developer in Foxglove, we get visuals. But if you're developing an application, you can use Python, C, C++, whatever. And you subscribe to these topics. It's a
these are the
that we see on the left. Yeah. So we see the camera, the bounding boxes, occupancy grid, the fusion model.
Okay, so now what about if we want to change the settings on the camera system? Like what do we do then? Or what's one way we can do that?
Absolutely. Good question. So there is an API to control all this. You could do it from Python or C. We also have just a simple web interface that uses that API.
Web interfaces from the camera itself.
Everything is still running on the platform. So it runs a simple web server that streams all the same ROS topics, but now it's streaming them over a WebSocket.
Okay.
So we can connect to the ROS topics from HTML and JavaScript.
And that's neat. It's pointing out the green is the human.
Exactly. Yeah. Cool. So this is showing the segmentation. And again, we've got the radar on the bottom. And then to configure, now, of course, this can be built however the customer prefers, but we've got various settings here. So for example, we can get into the radar settings, change the frequency, the range mode,
looks like a nice simple interface and way to easily adjust things.
Yeah, exactly. And there's, lots of parameters that can be configured like any of these systems, but
So that's a development tool, right?
exactly.
It's not an end product. It's a development tool, and for i.MX 8M Plus.
Yeah. So it's a development platform, though packaged, while not a sort of point solution,
Yeah,
it is packaged. It's fully waterproof, IP67.
could be used as is, but it's the idea is you'd build your own
Exactly.
version of it.
But for developing, it means you can order one of these, bolt it onto your robot, onto heavy equipment, take it outdoor, you're ready to start developing and running models right away.
Right, and then the beauty is it dovetails with all the existing ROS and communication stacks and Zephyr and everything we're already using in most robotics
It
applications.
makes it kind of seamless for the developer perspective.
I think if you were a roboticist, you'd find it very, very easy. Yeah.
Okay. And we talked about these multiple technologies. So what are some of the parameters of like lidar, vision, radar? Why would you use all three in a single application?
Yeah, that's a great question. So the LiDAR, now there are many, many types of LiDAR. We see on the robot here, this type of LiDAR is great for a real-time application where you're trying to find obstacles, but it's one plane.
Okay.
Um, the some of the larger lidars, which could be producing, a 500,000 points per frame, they're great for data collection when building data sets. You get very rich data, but the flip side is very expensive. So on the data
And lots of data to deal
and
with.
lots of data to
Yeah,
deal with.
yeah.
So that's fine when you're building the data set, but then you need to train a model for a simpler sensor. And that's where camera and radar fusion comes into play.
But
You get a lot of the benefits of the LiDAR, but at a much lower
but we were
cost.
saying like lidar is measuring distance directly,
Yes.
and then how do we what do you want to say about comparing radar and vision
Sure.
capability?
Yeah.
Why do you want both of those?
Good question. So you can estimate distance with the camera, but it's very susceptible to lighting conditions, to the environment,
Goals.
obstacles.
Okay.
The radar gives you very good depth information, but it suffers from multipath. You don't necessarily know what you're looking at. The points are quite sparse. So by combining the two, the high resolution camera and the radar, we kind of get the best of both worlds. The camera, doesn't suffer from multipath except for mirrors. And it will see a person very well. The radar then gives you quality distance, and the two together gives you good spatial perception.
It's all about safety, right? So this is really giving you a robust solution to the problem you're trying to solve, not relying on just one technology to do it all, but picking the three to work together and compensate for each other in the areas that they're not an expert at.
Yes, and that's also sort of the next level of fusion where you can take the low level radar data instead of the point cloud and start actually making predictions of what you're seeing with just that. So for redundancy, now the camera can go away and we could still tell you if we're looking at a person or a car or a fire hydrant. So that's really important for avoiding
Yeah.
people.
Sebastian, to kind of tie it all together, can you use this robot here and kind of describe a scenario in how the different technologies are used?
For sure. So an area where cameras will often run into problems is dusty environments, fog, certain lighting conditions. And this robot's a perfect example. With the camera mounted, so low, it's a low profile robot. If this were driving over, a dirt or gravel, it'd be kicking up a lot of dust, which would certainly cause problems with the optics. So this is where systems like LiDAR and especially radar are very important because they see right through dust.
Okay, great. So again, this has been really fascinating. And we kind of started this off saying that can you really build multimodal sensing technologies into robots? And proof is in the pudding. We've got this hardware platform here with intelligence at the edge, so you're not relying on a computer or a cloud. And then you've got your development environment to make it simpler for someone to really piece it all together and have a working end application.
Yeah, it all looks great.
All right. Well, thank you guys again for another great conversation at the edge. For more episodes, check out the links below.